of these pumps is the rotary pumps. Rotary pumps, there are different types of rotary pumps. Rotary pumps are positive displacement pumps that don't cause pulsation. So it is less pulsation than reciprocating one. So no need to install pulsation damper. The inherent high efficiency of the rotary pumps make this design very suitable for lube oil, for seal oil, and other high viscosity oil surfaces. You will see around in the engine of the car that the used pump is a rotary pump, either gear or lube or vane or screw, and we will learn why. This one is called screw pump and this one is lube pump. Okay, the first one is a vane pump. Vane pump is consisting of the vanes. There is a vanes, this one, these vanes in these slots. Okay, and these vanes is mounted on a rotor that rotates inside a cavity. This is a cavity. This is a cavity. In some cases, these vanes have a variable length and or be tensioned to main contact with the walls as the pump rotates. An eccentric rotary vane pump, note that modern have an area contact with the rotor and stator. It consists of the pump housing, then rotor, then vanes, then a spring. We will watch the video to know how this pump operating. The coming fluid is coming from here, inlet and the outlet. One of the characteristics of the rotary pump that has no discharge, no suction valve, and discharge valve built on the casing. For sure there is an external on the piping system isolation valve, suction discharge. And for sure you have to open it fully open suction valve, fully open discharge valve. Second rotary pump is a gear pump. Gear pump is either to be external gear pump or internal gear pump. The fluid carried between the gear teeth is expelled by meshing of the gears, which cooperate to provide a continuous sealing between the pump inlet and the outlet. This is the external one. This is the external gear pump. The external gear pump, the fluid coming between the teeth, moving down between the casing and make it pressurized. The internal gear pump, this is the outer one, drives the inner one, or what's called idler gear on a stationary pin. The gears creates voids as they come out of the mesh and the liquid flows into the cavities. It depends on the cavity. As the gears come back into the mesh, the volume is reduced, and as you know, the liquid is not compressible, so it's pressurized. The liquid is forced to move out. Fluid is carried out between the teeth of the two external gears and is placed as they mesh. Gears are used, usually gears pumps are used for small volume flow rate, lube oil surfaces and liquid of high viscosity like asphalt and polyethylene. So lube pump, the fluid is carried between the rotor loops which cooperate to provide a continuous sealing between pump inlet and outlet. This is how the pump is operating. Suction, discharge, no valves, and you have to install pressure relief valve at the discharge of the pump. The fourth type is the screw pumps. Screw pumps is widely used in the positive displacement due to it can operate up to 100 bar and the flow up to 2000 meter cube per hour, and the range of viscosity is in terms of 10,000, 1,000, 10,000 centibars. Screw pumps carry fluid in spaces between the screw threads. The fluid is displaced axially as the screws mesh. The screw pump is either to be single screw and what's called progressive cavity. Progressive cavity. The fluid moving along the threads, along the shaft and coming out. Progressive cavity pump. They have a rotor with external threads and the stator. Usually the stator is in non-metallic material with external threads and stator and with the internal threads. So the rotor with external threads, as we can see, and there is a stator with internal threads. Here we can see the rotor threads are eccentric to the axis of rotation, so the moving fluid is coming in progressive way, and there is multiple screw pumps, 2 screw or triple screw. The 2 screw called twin screw pumps. Twin screw pumps as this type, 2 screws and the fluid coming in between the screws and the casing and moving out. And the triple one. These screws can be timed or untimed. Timed means as there is a timing gear, make a spacing between the screw so it's not in touching with each other. There is a certain spacing in favor of the timing gear. So the timing gear make a spacing between the 2 screws so it's not in touch with each other, and this is the most commonly used one. And there is untimed mean the screws coming in touch with each other like this one, the triple screw pump. Triple screw pump, there is a rotor, this is a male and the other is a female. So when this one is moved, the other is to move. The fluid flow is carried axially between the threads of the 2 or more closed clearance rotors so that the fixed volume flow of the fluid is displaced with each revolution. This design is frequently used for loop and seal surfaces. Okay, what is the range of these pumps? The flow and the pressure of these different types of these pumps is a figure how about the flow and the pressure can be classified between different types. What is the limitation? And for sure the actual limitation, this main realistic one is coming from the vendors. You have to go survey the website of each vendor as we discussed in part 1 and see different flow rate, because sometimes there is some certain changes in the flow and the pressures make its wide range more than others. So you have to survey to know precisely what is the actual volume flow rate located in each one. But we can see here that is for example the Planger one. The Planger pump is from 1000 to 30,000 psi and the flow rate is from 10 to 20 to 150 GPM. If you compare this numbers with a piston, you can see this piston is only about 1000 psi up to. The maximum is 1000 psi. So for sure the Planger is at a higher pressure, deliver a higher pressure than the piston. So if the charge pressure you need is a 15,000 psi, so most probably it will be Planger type, and you can specify it as Planger type, and you ask the pump vendors to supply Planger one. And so the pressure is up to 1000 psi and the flow rate up to 2000. Yes, if the pressure is low but the flow will become more. More than Planger. We can see that the metering is up to 7500 psi, is more than piston but less than Planger range. And in terms of the flow rate, it is the lowest one. You call it up to 1000 gallon per hour, not per minute. Take care. And it's usually used in metering surfaces, in chemical injection surfaces. The rotary have a less range of the flow and pressure. You can see that the gear pump up to 200 psi and the flow up to 300 GPM. This is a law with respect to the reciprocating, and the screw is much more higher than flow in terms of up to 5,000 psi in terms of pressure, more than gear, and the flow is 5,000 GPM. So it delivers, yes, more flow rather than the other types, but the pressure is less than the reciprocating one and more than the gear. The most commonly used pumps is screw pumps. Then you can use gear pump or loop pump if the pressure and flow is very low, like the loop oil pump in the car. The loop oil pump in the car just deliver certain small amount of the flow, the loop oil. If you requesting pressures more than 100 bar, so you have to specify reciprocating pump. If the surface is metering or chemical injection, so for sure diaphragm. If it's not, so you can choose between the plunger and the piston. So the third selection is reciprocating. The first one is centrifugal, second is rotary, and in rotary the screw one, and the third is reciprocating.
Rotary pumps. There are 4 types of rotary pumps: screw pump, gear pump, lobe pump, vane pump. In screw pumps, it is the intermeshing of the threads on the rotors and the close fit of the surrounding housing that creates one or more sets of moving seals in a series between the pump inlet and outlet. These sets of seals or locks, as they are sometimes referred to, act as a labyrinth and provide the screw pump with its positive pressure capability. The successive sets of seals form fully enclosed cavities that move continuously from inlet to outlet. These cavities trap liquid at the inlet and carry it along to the outlet, providing a smooth flow. The pump is so named because it has 2 gears that are side by side or external to each other. A drive gear that is driven by a motor rotates an idler gear in the opposite direction. When the gears rotate, the liquid, which is trapped in the gear teeth spaces between the housing bow and the outside of the gears, is transferred from the inlet side of the pump to the outlet side of the pump. The meshing of the gears on the discharge side of the pump forces the liquid out of the pump and into the discharge piping. The lobe pump receives its name from the rounded shape of the rotor radial surfaces that permits the rotors to be continuously in contact with each other as they rotate. Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes much in the same way as a gear pump does. Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other, and so all true lobe pumps require timing gears. Vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid during half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are: gear pumps handle more viscous fluids. The sliding vane pump suits both viscous and non-viscous fluids. Sliding vane pumps cannot handle dirty or gritty liquids. Vane pumps are ideally suited for low viscosity, non-lubricating liquids. Sliding vane pumps are used for vacuum services. Lobe pumps are used for food and beverage processing. Lobe pumps can handle both low and high viscosity fluids.
Many different types of pumps exist to assist fluid movement in a variety of systems. An external gear pump uses two gears rotating against each other to provide fluid movement. One gear is driven by a motor connected to a shaft. This is called the drive gear because it is driven by a motor, and it in turn meshes with and drives the movement of the second gear. As the gears rotate away from each other and come out of mesh, they create an expanding volume on the inlet side of the pump. This creates a vacuum at the inlet port, allowing fluid to flow into the pump. Then fluid flows into the cavities and is trapped by the gear teeth. As the gears rotate, a flow path is created around the outside of each one. Fluid trapped in the slots between teeth is carried around and discharged into the cavity with the outlet port. Meshing of the teeth in the center of the pump seals the outlet port from the inlet port. No fluid passes between the gears. The advantages of external gear pumps are their high speed and pressure, relatively quiet operation, and that their design accommodates a wide variety of materials. Disadvantages include bushings in the liquid area can become worn and that they have fixed end clearances. Internal gear pumps are exceptionally versatile. This type of pump has one inner gear which is inside a second outer gear. The inner gear has a shaft driven by a motor and has teeth that protrude outward. The outer gear has teeth that protrude inward toward the center of the pump. As the inner gear rotates, it meshes with and moves the outer gear. Liquid is trapped in the gear spaces and carried from the inlet to the discharge. A stationary crescent-shaped divider separates the intake and discharge portions of the fluid. Advantages of internal gear pumps are a smooth and almost pulseless flow, and slightly more horsepower for its size. Disadvantages are its higher cost, limited size range, low to moderate pressure ratings, and few sources of manufacture. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor. The vanes are on an off-center drive shaft. As the shaft rotates, the variable length vanes slide in and out to maintain contact with the pump housing. The tension in the vanes is maintained by either springs or hydraulic pressure. As the vanes rotate, they create chambers of varying sizes within the pump. Fluid enters at the largest chamber. As the vanes rotate and retract, the chambers get smaller, forcing fluid to exit through the discharge port. The advantages of vane pumps are that they can handle low viscosity fluids at relatively higher pressures, can dry run for short periods, and develop a good vacuum. Their disadvantages include complexity and their unsuitability for both high pressure and high viscosity fluids.